My name is Karthik. With my team members are Mohammed Abdul, Mohammed Usman, and Mara Ayub. Our project is a smart home system. Now, there are a large number of smart home systems that are actually available in the market nowadays. And the most common thing that you find in all of them are stuff like, turn on lights, turn off lights, turn on fan, things like that. What we have tried to do with our smart home system is try to think of what future direction smart home systems can we go to. For instance, maybe something like a smart fridge or something that will tell you how much of something is there in the fridge. To that extent, last semester we built a platform that can actually determine how much of an item is available by saying, oh, you have more than enough, you have sufficient amount, or you probably need to go on. Last semester we had also built an HVAC switch because sometimes classes are best. And we had made a design for a smart lock. For this semester, for senior design 2, we have basically improved on the lock and we gave it and locking and unlocking system that's actually frequency based. Now most electronic locks that you find in the market, all of them use a number keypad combination to unlock the Ours uses frequency combinations. Now, some of you might ask, why frequency combinations? I say, why not? Number keypads are actually facing you, so someone might be able to see what number you're actually putting in. With frequency, the person can't really see what frequency you're putting in. There might be some things of, hey, someone might detect what frequency pattern you're using to unlock the door. But you can always use an AU escape, but we just want to put like this at this point. An additional thing that we can, an additional security feature that can actually be done with the lock is that the frequency patterns can be given by phone by particular apps that come with the smart home system. And each phone can be identified by the lock itself. And each phone can have, each separate phone can have its own unique code, if you will. And that way, even the person cannot just go randomly and, give his own frequency pattern. He needs to have a particular phone to do it. For this semester, we actually just built a locking system. We didn't do the phone identification part of it. It uses the pattern of frequencies to unlock and unlock the door, and of course, as we want it to be as smart as possible. Instead of any normal lock, if you put in the wrong combination, you can put it again. It does the same here, but let's say you're on a third variable pattern, and a code says it's perfect and power, someone's being patient and wrong. The lock will realize that it is not really a mistake, and instead of asking you to redo the entire pattern, it'll ask you to just use that particular frequency. Okay. Our idea for smart home projects, smart home system that can actually go in the future was quite large, and this kind of a smart lock and locking and unlocking system is actually just a small piece of what we thought it can go to. We had other ideas too, and we felt this would be the best thing to build. And we have a working prototype that uses a two frequency pattern thing to unlock and unlock the door. It'll be at our desk outside. And if you have any more questions, you can ask us.
I'm not sure I understand. So you have something like a cell phone that is completely digitally for the how do you generate the frequencies? And are you sending an analog signal to the frequency?
No. The locking and unlocking system is just for the door. The fridge operates the door.
Okay, so this is frequency system. So
the frequency system is to basically lock and unlock the door.
that's how do you generate the frequency?
There are actually a lot of.
In the front door, we actually have a device that will receive audio frequency signal.
So it's an audio signal.
Yes, sir. And you can generate that from a smartphone app. And currently we're using an auxiliary cable that right out of the door. You can just plug it directly into your phone and get all the frequencies that you want to get.
So if I understood correctly, that's one basic system, then you said to make sure that the phone is the correct one, the unique NEI.
Yes, NEI, or even if you want to say, you identify the phone, very large identify the phone, then you can, verify that this is a phone.
What I'm struggling to understand is if you have this whole system with a phone that has unique identifier, a digital system that can maintain having keys and encryption and digital signals and type of things, while going to the property and everything, or the signal that need to get the
Actually, the only space from the phone is basically just identifying the phone. It is, when we had our idea, we basically built our idea around like Bluetooth, because we consider that everyone carries a phone with themselves. A lot of people actually need their Bluetooth on. So the Bluetooth ID can be saved to the receiver, and you can check the ID and then check the code or the pattern, frequency pattern that it is receiving. And that's actually
So I guess my audio, why not just flash the screen, for example, and how about a code to the screen?
Well, right now we're using an auxiliary cable, and that thing is people surrounding you can't really tell what you're feeding in, so that they can't copy it per se. And this way it's more secure.
Can you send that audio file to somebody else? So like say your uncle was coming over and you can be like, here's what you need to get in my house, and have it pop up his phone.
Right, that's when we actually make an app that has actually been programmed. But right now we're using a general app that creates a single tone frequency, which is being accepted by the microcontroller. Right now we're manually putting in the pattern, and we're using a speaker to know when to put in what. Like the speaker notifies that it's second level, put in the second frequency right now, the third frequency. That's how we do it.
Have you tested it at all?
Yeah, our prototype, I would say, it uses two frequencies. The first frequency has to be 16 kilohertz, and the second frequency has to be 1000 hertz. And about like 5% plus or minus, it accepts the frequencies. Beyond that, like it just rejects the frequencies, it rejects the frequencies.
It's almost like a garage door.
Just the security system of the garage door. The actuator, we have actually showed it using we made a box with a door on it, and when it's supposed to unlock, the door opens automatically. So basically this will work on any system.
So if a cop is going right next to your home, there's a chance that they will.
No, but
Not really.
specific.
What we have done is we have kept a distance sensor. So the idea is that you're only standing in front of the door for a couple of seconds. So the distance sensor is always checking how long someone is there. So even if like a crow flies past it, or a bird flies past it or something, it will not trigger. It will not ask. It will not wait for frequency. You need to be there for like a couple of seconds, and then it will wait to receive the first frequency.
So just brainstorming here with you.
Yeah.
Maybe you can use some of the learning system stuff that you do in RF and actually have the door generate an audio signal that you can just record and play back and then out, as opposed to writing a separate app. I mean, that might make things a little simpler. Basically, when you're inside and you push a button, it generates the signal, and then you can send that to your friends or
Right.
relatives.
And what we're trying to do is basically we can change the signal at zero, so it's not like, somebody can get a hold of your phone and they can go out of your system, So the key is basically it's not a single key, you can use any other phone to create the key rather than they have the phones. And we're thinking about that, there's different possibilities we can go from there.
So this is the end of your senior design 2 experience. When you started senior design 1, you're required to identify specific performance goals or metrics that you have to achieve. And by the end, you have to have some type of numerical benchmark that says if you achieve what you set out to achieve. I don't see any numerical or quantitative performance evaluations that you've got. Maybe you have on the poster wall.
Yes, we can thank the speakers.